Hello, this is Mrs. Taylor, and I'm going to walk you through how to sketch the graph of a quadratic inequality. So, to start with, just keep in mind that when you're asked to graph, that means that you are going to shade part of your coordinate plane. When they ask you to solve, that's when you have to draw the segments on the x-axis. So what we're going to do first is we're going to find out some things about our parabola. And we're going to find out the y-intercept, the vertex, and the zeros. So the y-intercept is pretty simple. It's the c value when your expression is in standard form. And so our y-intercept would be 12. Our vertex, we would get the x value of the vertex by the formula the opposite of b, which would be 8, over 2a, which would be 1. And then that would be 2 times 1 on the bottom would be 2. 8 divided by 2 is 4. So the x value of our vertex is 4. Now to find the y value, what I do is I take the x value, plug it in for x, and then evaluate. I can use my handy calculator to do that. So we would get 4 squared minus 8 times 4 plus 12. And I get negative 4. So that means the y value of my vertex is negative 4. And then the last piece of information that will be helpful is if we find the zeros. So if I set the quadratic expression, it's supposed to be minus 8x plus 12. If I set the quadratic expression equal to 0 and then solve, then I can get the zeros. I'm going to try the x puzzle first. So 2, that works. Oh wait, it's negative 8. So that would be negative 6 and negative 2 would be my solutions for the x puzzle. And so 0 would equal x minus 6 times x minus 2. The solutions would be x equals 6 and 2, which would also be my zeros. Okay, so went through that really quickly because that's mostly review from our last unit, or last part of this unit. So I'm going to plot all those points. My vertex at 4, negative 4. My y-intercept is at 12, and that's not going to fit on the coordinate plane provided, so I'm not going to plot that one, but I am going to plot the zeros. And before I draw my parabola, I have to establish whether I'm going to use a solid line or a dotted line. That's one thing that's different with this as opposed to an equation. With an inequality, you have to represent whether you have an equal to symbol or not. And when there's equal to, use a solid line. If there's no equal to, use a dashed line. Well, this one's equal to, so I can make a solid parabola. And if this was just a regular quadratic equation, I would be done. But it's not. It's an inequality. So I have to shade the solution region because there are an infinite number of points that if I plug in for x and y, I get a true statement. And so I have to represent that fact by shading. And whatever points in the region I shade should be a solution. And so what we've done in class is we pick a test point. And you could pick any point you want, but as long as the origin is not part of your parabola, it's a really good point to pick because plugging in 0, 0 is really easy. So if I test 0, 0, if I plug 0 in for y and 0 in for x, it would look like this. And what I'm going to do to show that this is a test point is I'm going to put a question mark above the inequality to show that I don't know if that's actually a true statement or not. So 0 squared would be 0. 8 times 0 would be 0. So all I'm left with on this side is 12. And 0 is in fact less than or equal to 12. So this turns out to be a solution. And because it's a solution, that means that point needs to be in my shaded region. So I'm going to shade the region the point is in, which is the region outside of the parabola. So all I do is just shade in that region to show that any point in this region would be a solution. If I plug it in, I get a true statement. But also because the parabola is solid, any point on the parabola would also be a solution. So that is how you would graph a quadratic inequality.